What are they? These speed bumps are able to generate electricity from cars that drive over them. This energy can then be used to power street lights, traffic lights and road signs, etc. Any energy not used immediately can also be stored and transferred to the national grid. The speed bumps use piezoelectric sensors that generate power by converting some of the force applied by the car into electrical charge. The force applied by the car, multiplied by the distance that it depresses the piezos, is the amount of useful work that can be done. The ramps consist of panels that go up and down. When this happens, a cog is set in motion under the road. This turns a motor which produces mechanical energy. Energy is stored in lithium batteries.
We try to use some approximations to evaluate whether there is a significant benefit to using energy-generating speed bumps by doing some simple calculations. Financially, if the time the speed bumps take to save as much money as they cost is reasonable, it is worth using the energy-generating speed bumps. Firstly, we want to know the cost. From Wikipedia, it takes 460,000 build 146 energy-generating speed bump in the UK, so we use 460,000 divided by 146 to calculate the cost for each bump, which is £3,150. The principle of energy-generating speed bump is to return mechanical energy into electricity. Therefore, we want to know how much mechanical energy can be generated. Then multiply it by the efficiency of the machine should be. For a supermarket or shopping mall, at least 100 parking spaces are required. In the UK, working time for a shopping mall is 10 a.m. to 8 p.m. normally. The average parking time is 40 minutes, so there are 1,500 cars per day. Here, mu is the efficiency, h is the height of the speed bump, m is the mass of a car, g is the gravitational acceleration. After we know the electricity generated, we can calculate the money saved by 14 pence per kilowatt hour. That is for one car, and there are 1,500 cars a day, so we times 1,500 to get money saved for one day. Big M. We use 3,150 divided by big M to get time required to get the money back. However, the data we use are not very reliable, and we don't know how to figure out the efficiency because the actual structure is too complicated. So we use some data from more professional research.
Real-life applications. These speed bumps have already been tested in a number of real-life situations. They are built in places where drivers would be slowing down anyway, like drive-thrus, slip roads, and traffic lights, as well as in places where traffic calming measures are needed. Examples. Speed bumps created by a company called Motion Power were tested in a Burger King drive-thru in New Jersey. In time, these speed bumps could hopefully negate the large carbon footprint caused by such drive-thrus. However, in the meantime, while the speed bumps are still being developed, their energy production does not account for the energy wasted.
There are many pros to this technology. First of all, the energy would otherwise be wasted if it wasn't used to harness electricity, and the speed bumps would encourage safe driving and reduce the number of road accidents in the area. This green energy would only require one-time cost, and as the math shows, the one-time cost would be repaid quickly. The energy produced after this can be used as profit or for maintaining the speed bumps. These would also be silent and safe for the cars going over them.
There are many cons for energy-generating speed bumps. Firstly, the ramps cost between £20,000 and £55,000, depending on the size, which is a lot of money for initial outlay. There's a large range of energy production per hour due to the fact that different locations of the speed bumps would generate different amounts of energy depending on the number of cars going over the speed bump. Certain locations would benefit more than others, for example, shopping centre car parks, toll booths, traffic intersections, and services. Secondly, it is not a very efficient method of generating energy as there are alternatives such as hydropower, which in 2009 was generating 19% of the world's power, a figure these speed bumps could never compete with. There are also other alternatives such as solar panels, which can cost as little as £1,000 for a small-scale panel used on rooftop homes. Lastly, faults may occur with the mechanism that could be expensive and wasteful to repair. We think the Department for Transport should use the energy-generating speed bumps, but only in very busy areas. This is because our calculations have shown that there's a very quick payback for the initial cost and of the speed bumps when they're placed in these areas. This means that it's cost effective. Also, fossil fuels are quickly running out, and developing sustainable energy sources such as these speed bumps is very important.
There are other options when it comes to generating energy using traffic. For example, using the same idea as the speed hump, some scientists believe a more efficient alternative would be a speed divot.
This would be a flat surface that would be depressed more easily when a car drives over it. This would then cause a generator to spin.